Hi everyone. In this video, I'm going to build the frequency discriminator circuit in section 1 of your lab handout. Now what you'll need for this part of the lab is a 10K resistor, a 47K resistor, and a 1 mega ohm resistor. The 10K and 47K will be for the differentiator, and the 1 mega ohm resistor will be for the envelope detector. For capacitors, you'll need a 4.7 nanofarad as well as a 47 nanofarad. The 4.7 nanofarad will be part of the differentiator, and the 47 nanofarad capacitor will be part of the envelope detector. And you'll also need two op amps, one for the differentiator and one as a buffer. And then you'll need a few wires and then a 1N914 PN junction diode. All right, so the very first thing that I'm going to do is I'm going to connect my circuit to ground. Next, I'm going to connect the 4.7 nanofarad capacitor for the differentiator. Now this will be the smaller of the two capacitors you'll be using for this lab. So take the 4.7 nanofarad capacitor and place it in between two different nodes in the circuit. Once you have the 4.7 nanofarad capacitor, you can connect its negative terminal to the 10 kilo ohm resistor, which will then be connected to the inverting terminal of the op amp. Now a 10K resistor has a color combination of brown, black, orange. So take out a brown, black, orange resistor from your kit and connect one end of it to the negative terminal of the 4.7 nanofarad capacitor. Once the 10 kilo ohm resistor is in place, then you can connect the op amp to the differentiator circuit and make sure that the negative terminal of the 10K resistor is being connected to the inverting terminal of the op amp, which is the second pin from the top. Now, the last step for completing the differentiator circuit is connecting the feedback resistor, which will be using a value of 47 kilo ohms. A 47 kilo ohm resistor has the color combination of yellow, purple, orange. So take out a yellow, purple, orange resistor from your kit and connect one end to the inverting terminal of the op amp, and then connect the other end to the output terminal. Now that the differentiator circuit is complete, now we can add in our buffer, which will feed the output of the differentiator to the input of the envelope detector. So to do that, place the second op amp into the breadboard. Now connect the output of the differentiator circuit to the non-inverting terminal of the second op amp. And then the last step is to connect a wire between the inverting terminal of the second op amp and then the output terminal, which will go to the input of the envelope detector. Okay, so we have our differentiator circuit. We have our buffer, which will feed the output of the differentiator to the input of the envelope detector. And now it's time to actually build the envelope detector circuit. So the envelope detector circuit begins with a 1N914 PN junction diode. So take out a 1N914 PN junction diode from your kit and then connect it to the output of the buffer. Now that we have our PN junction diode, we can add the RC parallel configuration of the envelope detector, where the output voltage will be taken as the voltage across the capacitor. So to do that, I'm going to take a 1 mega ohm resistor, which has a color combination of brown, black, green. So I'm going to take out a brown, black, green resistor from the kit and connect one end to the negative terminal of the PN junction diode and the other end to ground. Next, I'm going to connect the 47 nanofarad capacitor, which is the larger of the two capacitors that we'll be using in this lab, and I'm going to connect it in parallel with the 1 mega ohm resistor. And the last thing I need to do is I need to connect the negative terminal of the capacitor and resistor parallel configuration to our ground rail here. So to do that, I'm going to take one of these short brown wires and I'm going to connect that between the negative terminal of the capacitor and then this ground rail here. Now we've built a differentiator circuit. We have our buffer, which feeds the output of the differentiator to the input of the envelope detector, and then we have our envelope detector circuit. But there's still a few things left that have to be done before we can actually perform measurements on our frequency discriminator circuit. So the first thing that needs to be done is that we need to be powering both of our two op amps. We need to power each op amp with V plus, which will be plus 5 volts, and then the negative power supply, which will be minus 5 volts. So I'm first going to connect V plus, the positive power supply, to the first op amp. Once I do that, I'm going to connect a wire from the positive V plus row of the first op amp to the V plus pin of the second op amp so that both can receive the same positive power supply voltage. And I'm going to do the same thing for the negative power supply. So I'm going to connect the negative power supply of the AD2 to the V minus pin of the first op amp, and then a short wire to bring this negative power supply voltage also to the V minus pin of the second op amp. Note that in both op amps, the V minus row corresponds to the very bottom row of the op amp. Now that we're powering both of our op amps with plus and minus 5 volts, we can actually input the voltage from the waveform generator to our circuit. So to do this, take the yellow cable representing the arbitrary waveform generator 1, labeled W1 on your AD2, and connect that to the positive terminal of the capacitor, which goes directly to the differentiator. Now, something that I've realized that I've just missed is that I haven't connected the non-inverting terminal of the op amp being used in the differentiator, that I haven't connected that terminal to the ground rail. So the non-inverting terminal of the op amp in the differentiator has to be connected to the ground rail so that both the non-inverting and inverting terminals will receive the same voltage of 0 volts. So this is it for building the frequency discriminator circuit. In the next video, we're going to perform various measurements on the differentiator portion of our frequency discriminator circuit.